4.4, college prep math. Looks like we're going to be solving what?
Equations.
What kind of equations?
Radical.
You aren't cool. You aren't cool until you know how to solve radical equations and inequalities. You aren't cool until you know how to solve radical equations and inequalities, okay? So, I have an idea. Want to hear my idea?
Yes.
Let's be cool by the end of the hour. Sound like a plan?
Okay.
All right. Hey, radical equations and inequalities for 4.4. I told you have your calculator handy. This is going to be a pretty easy section compared to what we've really been looking at. I didn't think that the domain range and the graphs that we looked at in the last section was all that difficult. 4.2 is still the one that's been the most difficult for us. But I feel like this one's very manageable for us today. So in order to answer our question, how can you solve a radical equation today, we need to be able to solve or establish two goals today. Anybody want to read that first goal up there for me?
Solve equations containing radicals and rational exponents.
Okay, so anytime you see this word rational exponents, I've told you always think of rational exponents as what?
Parentheses.
It's kind of like parentheses, but the word rational exponents,
Oh, fraction.
treat them as a fraction, you bet. Where the denominator is like the index and the numerator is like the power. And then we're also going to look at solving radical inequalities. So the vocab is not difficult today. It's actually pretty simple. How do I move this? There we go. Didn't need to look at that the whole time. All right, radical equation. Volunteer to read that for me. Go ahead, Sophie.
Equations with radicals that have variables in their radicands and are called radical equations.
Okay, so an example would be something like this. Underneath maybe a square root sign, we might have 2x minus 6 equals 20. Okay, radical equation because there's a variable underneath what? Whoops, didn't want to do that. There's a variable down here underneath the what? Yeah. Okay, so that makes it a radical equation right there. Okay. Today we're going to talk about extraneous solutions. This might be something that might be new for some of you. Okay. In here it says raising each side of an equation to the same exponent may introduce solutions that are not solutions of the original equation. These solutions are called extraneous solutions. When you use this procedure, you should always check each apparent solution in the original equation. Okay? You should what?
Always
check. Sorry. I'm just keeping it real then. Guys, extraneous solutions. Here's what this means. All right, let me give you an example. Okay? I'm driving down the highway, and my tire blows out. And I call up and I say, hey, Sophie. And she's like, what? I said, my tire blew out. Bring me a tire. So Sophie says, okay, I'll bring you a tire. But when Sophie gets there, does she think she's solving the problem? Yeah. Little does she know she brought the wrong size of tire. Okay? So here's the deal. What we're saying is this. The tire that she bought while she was doing the right thing, she just happened to bring the wrong tire. Was she bringing the right item? Answer 100% yes. Did she bring the correct size of item? No. So I might say this tire is extraneous, Sophie. It's the right thing to bring. It's just the wrong size. Okay. And when we talk about extraneous solutions, we're going to run into things mathematically as we go through procedures here. We're going to say, oh, the answer is 4. But by following those rules of math to get 4, what we need to do is go back and put 4 back into the original equation and see if 4 actually makes the equation true. Because sometimes we get answers that are going to make this false, okay? So an extraneous solution is a solution that does not work. Basically, they are telling you to do what, kids? Okay, and I know that elementary school, check your work. Middle school, check your work. I don't preach that very often. I ask if you think an answer is reasonable. This would be the one section right here where I'd say, make sure you do what? Check. Extraneous solution means, yeah, I know you got that number, but it's not the right answer. Okay, and we'll look at examples, okay? All right, rational exponents. Whole numbers or fractional exponents, you know that. Radical expressions, you know what they are. They're any expression with a radical sign in it. Okay, it's basically an nth. It has an nth root somewhere. Okay, solving quadratic equations. Okay, second degree equations to be solved by factoring or using a quadratic formula. Guys, in order to solve some quadratic equations, they have to be equal to what? 0. They have to be equal to what?
0.
0, okay? So, ax squared plus bx plus c must equal 0 in order for us to use the quadratic formula. To find our roots, what is the formula? How would you solve for x? You guys should know this.
Opposite of b plus minus square root of b squared minus 4ac all over 2a.
Come on, put a little pep in there. X equals plus squared.
Okay, so you know that. And guys, do you remember how to get to that quadratic formula calculator that we've used in here this year? Okay, I think I've got it open today here. Remember this one right up? Oh, where is it? Is that it? This one here, you remember that one? We're going to use that a little bit today, so make sure you remember how to get there. It's in the online calculators on my page, or the online calculators and resources part of my page, so we'll go to that, okay? All right, let's forge ahead, page 2. So guys, core concept's pretty important today, I think. Okay, core concept is talking about solving radical equations. Okay, we already know what a radical equation is. It has a radical sign. There's some variable in the radicand. And they kind of give you a roadmap as to how to do this. And this is kind of the steps right here. This is kind of step 1. So step 1 says to do what, kids? Okay, so we've got to get the square root or some root equal to something over here, if possible. Okay, or if it's necessary. Now, there's going to be times when it's not necessary, and I'll show you what that looks like. Okay, so this would be like my step 1. Okay, step 2 then. Raise each side of the equation to the same exponent to eliminate the radical and obtain a linear, quadratic, or other polynomial equation. So if I'm taking the cube root of something, what power do I want to raise everything to get rid of that root sign? If I'm taking the cube root, I would raise it to the power of 3. And then finally, use your rules of mathematics. But again, right here, use your rules of mathematics to solve, but it always says to do what? Okay, so let's look at example 1 right down here. Okay, our job is to solve this right here. Step 1 says get the radical all alone. Is the radical all alone down here in 2 times the square root of x plus 2 equal 8? No. So what do we have to get rid of first, kids? Got to get rid of this 2. In order to make x plus 2, square root of x plus 2 be alone, we've got to get rid of this 2. So what are you going to divide them up both sides by?
2.
Okay, so what will the 2's do right here? And you're left with the square root of what, kids?
X plus 2
Equals what?
4.
Now I want you to understand something today. In this section today, if I say what's the square root of 49, some of you are used to saying, well, Parson, that's either positive 7 or what?
Negative.
Okay, I want you to treat that as a positive 7. If they want the negative 7, they will ask you this. What's the negative square root of 49? Well, square root of 49 here is what? This answer would be, okay, you understand that? So when we see square roots in this section, or any root, we're assuming it's positive unless it's like a cube root of a negative number. Just understand, if I have an even exponent up here, or I'm sorry, an even index, even indices can give you either a positive solution or a negative solution. I'm telling you, if there's no sign out there, treat it as what kind?
Positive.
Now understand this, like the cube root of, I don't know, negative 8, what's that going to equal? Okay, you understand the difference there? Okay, so make sure we're clear on that, okay? All right, so kids, really, I have the square root of x plus 2. I don't have an index written out there, but it's assumed the index on that function on the left, or the expression on the left, is what? So we've got this square root all alone. So the second one says take both sides to the power of that index to get rid of the radical sign. So we're going to take both of these expressions to what power now, kids? So if I do the left, take that to the second, I better do the same thing to the... Help me out, kids. What's going to happen to the square root sign after I square it? It drops right out. This becomes x plus what?
2.
Equal to?
16.
By golly, kids. Are we getting close in solving for x now?
Yeah.
What is x? X is going to be 14. Whoa. That is radical. Good one, Rat. Give yourself a pat on the back for that one. Are we done?
Yeah.
Are you sure?
Check work.
Better check. Let's throw 14 in. What's 14 plus 2 in the original equation?
16.
What's the square root of 16?
4.
4 times the 2 make 8. We're good then, aren't we? Okay, you guys try the next one on your own. See what you come up with.
Okay.
Oh, holy smokes. Once you got an answer, check with someone around you, see if you agree. If you disagree, talk about why you disagree.
I got a little lost.
You want to start me?
What did you, yeah, sure.
All right, yeah, we're going to try and get this root part right here alone. So I see a -2 over here kind of hanging out. What do you probably want to do to both sides first? All right, so let's see what that gets us. So the 2's will go away. And what will we have on the right?
Keep rid of the on the left.
Okay.
Equals 5.
Equals what?
5.
Okay, so do I have a root kind of by itself right now?
Yep.
Nope.
So what do you want to do to both sides now?
Take it to the power.
That was awesome. So I'm going to put parentheses around that and raise that to what power? Third, right? If I raise the left side to the third, I better raise the...
Right.
Okay, what happens over here on the left, kids? What is 5 to the third? Yep. So hey, we're in a place that we're comfortable right here. Add 5 and then divide by what? If I add 5, that turns into 130 divide 2. What do we get? How many had 65 for that? Good work.
Wait, I'm guessing the cubed root and then to the third I just cancel. Right.
Yes, correct.
Oh, that's so much easier.
Got it?
This is beautiful.
Okay, so let's see if we can't apply this to a real life problem right here. Guys, example 2, this would be a place where you kind of want to know how to work with this stuff. Meteorologists might work with it, especially down in Florida, or along the coast, or in the Gulf, whatever. It says in a hurricane, it says the average sustained wind velocity in meters per second can be modeled by the function V of P equals 6.3 times the square root of 1013 minus P, where P is my what, kids?
Air pressure.
Air pressure measured in,
Millibars.
anybody know what millibars is? That's how they measure the pressure, right?
I thought you said Malbar. I know, I was like, that's
Millibars, okay? So it's going to be the pressure at the eye of the storm, or at the center of the hurricane. It says estimate the air pressure at the center of the hurricane when the sustained wind velocity is how much here, kids? 46.2 meters per second going to be a velocity or a pressure?
Velocity.
So if I'm going to apply this, Sarah, are you good?
What? Yep,
Are you
just
good?
cleaning Lexi's shoes.
All right, well, you're
Why
done
do
here.
I
Why don't you
clean
have a
your
seat
shoes?
for me?
It's so satisfying.
She's sitting on the floor.
Okay. What's this going to take the place of? Okay, so in for V, I'm going to plug in what?
46.2.
That's going to equal 6.3 times the square root of what?
113 minus P.
1013 minus P, right? Okay, you guys take a second and on your own solve for P right now and see what you come up with. Got to get the root alone first, so you're going to have to do something before you can get rid of that root. What's your first step here, kids?
Oh, I did the same thing.
Can you subtract?
No, I'm multiplying.
Oh.
Am I good so far, kids?
Yes.
No, no. Stop.
All right, what's the next step?
You gotta square both sides.
So 46.2 divided by 6.3 was a 7.33. Somebody run 7.33 squared for me.
53.7.
What are you going to have on the right now, kids? Okay, so subtract now how much?
1013.
Okay, so take 53.73, subtract the 1013.
Negative 959.27.
when I get rid of the 1013 on the right, that's going to equal negative 1p. So from this right here, what are the negative signs really going to do to each other? So p is going to end up equaling what value? So in this particular hurricane, where the wind velocity is 46.2 meters per second, what's the air pressure at the center of the storm? 959.27, but that represents the number of millibars. Is it okay if I put MB down there? How you guys feel about that? Really, is it any different than what we've looked at so far? No, it's just a story problem. Plug your numbers in, run the same process. That's all you're doing. Okay? Show of hands, how many are on pace with me right now, feeling decent about this? Okay? How many say, ooh, this is a little easier than some of the things we've been looking at lately? How many are like, ooh, that's a good thing?
A little bit more like.
How many feel like if they could do a backflip, they would do a backflip? Who can do a backflip?
I'm just kidding.
You can?
Yeah.
Want to demonstrate?
Not like a, not, I can give back handspring, not like a
Do it,
full
do
on.
it, please.
I
Do
did
it,
not
do
do
it.
it.
Please.
Oh my God, I'll do it later. I can do it, I
I'm
promise.
doing
The
it.
camera like gets your neck snapping and stuff. It's like,
What a pose is that?
I'm going to have you sign a waiver first.
So you don't sue. I did one during track. That's what they look like.
Did you really?
Lindsay's on me, you can ask her about it.
Probably a good thing I didn't see you. I'd have probably yelled at you. Okay, kids, this is what I want you to put a star by, because what we're going to start looking at is a situation like I talked about, where kids, we start running into situations when we solve an equation, we're going to have what type of solutions? Extraneous means, hey, you found an answer, but you better check to see if they're right. So we're going to start looking at this here. So put a star by example 3, and let's roll with this. Oops, what happened there? Okay, so let's get started on this. It says solve the following equation. 2x plus 7, root of 2x plus 7 is equal to x minus 4. Now guys, the difference in this is that, yeah, I have a root on the left, but instead of having just the x completely on the left, x is also on which other side? The rules don't change at this point. Now, I wish I could tell you you had to follow those rules every single time, and they worked every single time. Unfortunately, when we get into the next page, that's not always going to be the case, and I'll show you why here in a second. But understand this, we're starting out with how many roots again? 1 root, 2x plus 7, right? Okay? Guys, is that 1 root 2x plus 7 all by itself? So what should I choose to do to both sides right off the bat then?
Square.
Okay, so I think we should square both of these here. So I'm going to say, okay, first thing we need to do is square these. Now if I do that to the left, I have to do it to everything on the right. So that means, what are you going to have to put around x minus 4 before you... Yeah. Okay, so this means that really you're doing the x minus 4 times x minus 4, right?
Yep.
Okay, so help me out here, kids. On the left up here, wouldn't that just be 2x plus 7?
Yeah.
Okay, but on the right, help me out. What's the x times the x? Okay, so that's the x squared. How about inside, outside? Negative 4x, inside's another negative 4x. So when I combine negative 4x, so x squared minus 8x, and then you think FOIL, we did f for the x squared, the outside, inside combined in negative 8x. What's the negative 4 times negative 4 for last? Yep. So that's what that right side's going to go ahead and square out to be. Now kids, this is where we start running into things right here. All of a sudden, instead of solving linear equations, we're now dealing with what type of equation? You know, the quadratic here. Quadratics, we like to solve quadratics when they equal what?
0.
So we better make sure we're equal to 0. Are we there yet? How about you say we get this 2x and negative 7 out of here. So let's subtract a 2x and subtract a 7 at both times. So do you guys agree a minus 2x on the left would align with negative 8x over here? So put it right there. You okay with that? And then a minus 7 would align with what on the right?
16.
Okay, so obviously the left side is going to be what, kiddos?
0.
X squared. Now, I can make you factor this. I can make you write out the quadratic formula, or I can let you use quadratic formula calculator to find your roots. All right, so let me get there, kids. Yeah, I need to get a way to type up here.
It's snow, so it could be like summer.
All right, what was the A value there?
1.
1. What's the B value? Negative 10.
Yes.
And what's my C value?
9.
Okay, so when I go ahead and calculate this right here, answers I get are what and what?
9 and 1.
So it's telling me 9 works, and it's telling me that 1 works. So if I go back into my notes right here, so I'm going to come over here and I'm going to make a little T-chart, because this is interesting. This is telling me that x is equal to, and I should write this by, what's this mean? It's not UFC, it's QFC. Those are the solutions we get, right? I'm going to come over here and make a little T-chart. I want to talk about those two solutions. I'm going to put x equal 9 up here. Let's do it this way. X equal 1, x equal what? Okay. Let's go back to our original equation. Root of 2x plus 7 equals x minus 4. Guys, I don't care what we're talking about, but is there a sign in front of this root at all? So I'm looking for a positive root, aren't I? So this is going to become the square root of 2 times, what am I going to plug in for x?
1.
Plus 7. That should equal 1 minus what?
-1.
Okay, check this out, kids. Got to be careful on this, and this is where we start running into problems. What is 2 times 1 right here underneath this root? 2 plus a 7? 9. Isn't that the square root of 9 right there?
Yeah.
But what is the square root of 9? And we're keeping it as positive 3 because there's no sign out here. So in this case, we're going to say, well, if I plug my values in, I get 3 on the left. What do you get on the right?
-3.
Statement true or false?
False.
This is not what?
Not a solution.
This is not good. We would say x equals 1 is it okay if I write it like this?
My initials.
X equal 1 is an Ella Smith.
You.
What do I want that really to stand for?
Extraneous solution.
Extraneous solution means we followed all the rules of mathematics to get 1, but when you put 1 in, we get a false statement. That's not good. Let's check 9. Root 2 times 9 plus 7. What is 2 times 9, kids?
18.
18 plus 7?
30. 25.
25. What's the square root of 25 over here on the left?
5.
What's 9 minus 4 on the right?
5.
Is that comparison good?
Yeah.
This one's okay. So we would say x equals 9 is a solution. I want to show you something here. So x equal 9 is good. We would say x equal 1. Not good. Okay. I don't know if I had that graph or not. I can't remember if I did. Let me look up here. Decimals. Do you see decimals open anywhere? Is that it?
Right there. Yeah.
No, that's not the one I want. What's the left side of your function say there, kids?
Square root of
2x plus 7.
Okay? And then what's the next one say? Is it x minus 4?
Yes.
Ah, shoot. Check this out, kids. This is the left side and the right side of the equation we just dealt with. Now, I know we found two solutions, and we talked about one being workable, and we talked about one being extraneous. But guys, if this is a graph of the two functions right here, how many places do those cross?
1.
One place, implying that there would only be how many solutions?
1.
Okay, so if I take a look at this right here, my point of intersection is right up here. What's the x value to that point?
9.
What did we get for an answer?
9.
Okay, are we okay with that? Okay, let's move. Is that the last one on that page?
Yes.
Okay, next page then. Okay, I think I want to get this example done right here, this next example done, and then I think we'll call it good. Okay, kids? All right, first of all, solving an equation with what?
2 radicals.
Okay, this is where our rules kind of go away. We've been looking at everything with how many radicals in it.
1.
We know how to solve stuff when we get it down to one radical. Okay, but what do we do when we have two radicals? Well, we've got to find a way to take two radicals down to
1.
one radical, and I'll show you how this works. But it says, look at a what?
Cross.
Okay, so I'm going to go back to decimals. I'll type these back in. I'm going to go square root of x plus 6. Was that what was under the root there?
Yeah.
And then is there a plus 1 on the outside of that?
Yes.
Okay, that's the left side function. Here comes my right side function. It was square root of
7 minus.
square root of 7 minus x.
Carson, I got a question.
Yeah.
Will this final test be before Christmas break?
Definitely. I'm pushing. I want it to be.
How many sections are there?
Only 2 to go. Okay. All right, guys. Just zooming out on this. How many points does it appear are going to intersect?
1.
What's it look like the x value is going to be for us here? Okay, so let's talk about this, kids. Here's where we get going on this. All right. First of all, the question becomes, how in the world do I handle two radicals as opposed to just one? Well, here's how you do this. You basically say, well, I got to start by squaring both the left and the right. Okay? Now I'm going to show you what happens. The right's fairly easy, isn't it? This just becomes what?
7 minus.
Okay, but this is kind of problematic because you don't have just a root. You have a root plus what?
1.
You guys agree? It says take this part in parentheses times itself when I square it. Okay, so I'm going to go to a different page here. Let's do that. Let's FOIL this out together. This is really the square root of x plus 6 plus 1 times itself when you're squaring it. So you guys need to help me with this because, gosh, I'm not sure I know how to do this. Okay, first, this times this. Just going to be what? Okay, those two roots, it's just like root 5 times root 5. That'd be the square root of 25 or 5. So root 5 times root 5 is just 5. So if I have root x plus 6 times root x plus 6, it's just going to be what? Okay, now we'll do the outside and the inside together. Here's my outside. What's 1 times root x plus 6? And what's in the inside? 1 times root x plus 6. So how many 1 root x plus 6's do you have? So this is going to become plus what then from this? And then finally my last term. What's the 1 times the 1?
1.
Thank you.
Which is what?
1.
Okay, what would the 6 here and the 1 combine to? So the left side is going to simplify to the following when you expand all this. It's going to simplify to x plus 7. Well, I'm going to call it this. X plus 2 root x plus 6 plus 7 here. Okay? Now, kids, by doing that, I've gone from 2 roots down to what?
1.
Now, once you get down to that 1 root, now your rules can start kicking in again, saying, hey, let's get this root all by itself. So I really want to get what to be all by itself right now. Okay, so let's start by subtracting a 7 here first from both sides. Ooh, that's good. What happens here? Yeah, your 7s just go away here. And they also go away here and here. So what we're left with is x plus 2 square roots of x plus 6 is equal to negative x. Agree first? Okay, what can I do now to try and get this minus a what?
Minus the x.
Okay. So what are the x's going to do here?
Cancel.
So we have 2 square root of what?
X plus 6.
What's negative x minus another x on the right?
Negative 2x.
Is that root completely alone, or do we have some work to do yet? There's work to do. Divide by what? Well, the 2's do.
Oh.
Cancel. So you agree that we have root x plus 6 equals negative x now? Negative 1x. Okay, so I'm going to take my work up over here. So up to here we go. Anybody have a thought now? Square it. Square it, Parson. Parson! Square it! Ooh, that's going to be a new basketball play. Square it.
Parabola.
Guys, when I square the negative x, you've got to be very careful over here because it's negative x times negative x, which is going to be what? Positive x to the, and this is going to equal x plus 6 on the left, right? Oh my gosh, there's that thingy again that we call a what? Quadratic. The quadratics are only going to work for us if,
Equals 0.
so help me rewrite this so it's of the form 0.
Negative x squared.
So you're moving the x squared
Yes.
to the left, negative x squared.
Plus x plus 6 equals 0.
Let's find our roots. You got no roots. You got no roots. Isn't that a song? Okay, never mind. Obviously, we don't listen to the same stuff. What's our answer going to be? We know by the graph our answer is going to be what? What's the x value here? Okay, let's go see what the heck happens up here. What's the a value based on what we have right back there, kids?
Negative 1.
What's the b value? I didn't want to do that. You said 1?
Yes.
What's the next one?
6.
Is this my enter key?
Yes.
All right, kids, calculate that, babe. What do we get for answers? Negative 2 and 3. Okay, x equals negative 2, x equals 3. Let's see what's going on here. We know the x value by graph is going to be what?
Negative 2.
Okay, let's just check out why negative 2 works and why 3 does not. Okay, keep in mind your original equation right up here. Keep in mind your original equation up here. Let's plug negative 2 in. So the left side will become the square root of negative 2 plus 6 plus the 1 on the end equals square root of 7 minus what? I don't like that. Hang on a second. Seven minus negative 2 really becomes 7 plus 2, doesn't it? Okay, what's this equal in here? Square root of what? Square root of 4 we're going to call positive 2 based on our functions, right?
Yes.
Positive 2 plus 1 makes what on the left? So square root of 9, we're going to leave it as what kind of a value? Is this okay? So do we like x equal negative 2?
Yes.
Yes, we love it. Okay, it's okay. Now let's check why 3 doesn't work. I'm going to plug in 3 plus 6, that root, plus 1, equals the square root of 7 minus what? Okay, what is 3 plus 6? Square root of 9? 3 plus 1? What's 7 minus 3 here?
4.
Square root of 4, though, would make this a... Is this good or not good?
Not.
Not good. So x equal 3 is not a solution, but what type of solution would we probably call it? This one here is extraneous. Kids, I think that that's probably a pretty good place to stop right there today. Are you with me so far?
Yes.
Seems a little more manageable?
Yes.
Okay. I did send out an online page. Won't be doing until Monday. We'll take a few minutes and finish up tomorrow. I don't think it's going to take me more than 10, 12 minutes tomorrow to finish up, and then the rest of the time will be work time. We'll have a short, quick quiz and that type of stuff. So.